I welcome you to a new lesson. In this lesson, we will get acquainted with the new concepts of expressions and context in GitHub Actions. In the previous lessons, we have already used both of these concepts, but now we will dive a little deeper into them. On the screen, we see nothing other than an expression and a context. So in this case, what I'm highlighting right now is the GitHub object, GitHub Actions. It's called the context. So when I refer to the GitHub object and take certain keys to get their values, that means I'm accessing the GitHub context. So what is an expression? An expression, GitHub Actions, is everything we write between these symbols, between the opening and closing ones. So in my specific case, this context is also an expression, but there are other types of expressions. There are different operators, and for example, there's the use of functions. So I can use a function inside here, and it will also be considered an expression, and that's exactly what we're going to talk about in this lesson. In the previous lessons, we worked not only with the GitHub context, but also with others. We worked with the input context. You can check which contexts are available in the documentation. I'll attach the link to the lesson. So indeed, we worked with GitHub. As far as I remember, we also worked with the inputs context. Next, throughout the entire course, we might even use other contexts in this lesson. Let's print out what we have stored in the GitHub object to the console. To do this, we will use a function as an expression. We can definitely, certainly, and indeed use the toJSON function and then pass this object to it. So in my case, this writing is an expression. It is the context. Well, in simple terms, throughout this course, I refer to this either as objects, or when I eventually access a key, I call it a variable, JSON. It's clear that this is a function that will print to the console in JSON format, whatever we pass to it. And we'll also see what's in this object. And this object contains a lot of data related to our repository. The only thing is, I started editing the 9th workflow, but maybe we should create a new workflow so that this one stays unedited in the repository. So let's create a new workflow. And we will definitely use a push as the event. In this segment, we will thoroughly explain and provide a detailed description of each step involved in the process, ensuring clarity and understanding while maintaining the original intent. I don't remember if I mentioned it or not, but our step, besides the name and the run command to execute, can also have an ID, and this ID will serve as a convenient way to find information about this step in the logs. Let's add an ID to it. And in the log, we'll print not only the GitHub context, but also a couple of other contexts from the documentation. So in this case, we'll utilize a multi-line transfer. Let's also print, as an illustration, for instance, the runner. In the runner, we will have information about the virtual machine. Also, what else might be interesting to us? Job. It will contain information about our job. And maybe also steps, information about our steps. So, job. And steps. Alright. Now let's commit and push and see what it returns to us, what's in these contexts, and whether we can use this data. So, our commit has gone through. Let's go to Actions. The workflow is starting. We enter this workflow and wait for it to finish so we can check the logs, or let's just go in right away. We have an error. So, as you can see, here we are currently in the process of retrieving and acquiring the various different objects and items. Currently, I can clearly see the various GitHub related objects, including the runner object. Additionally, the job object and its associated steps are currently empty, as the steps have not yet been executed. Apologies, but the context here should indeed be enclosed in quotes. And I'm committing and pushing again, and I'm checking again. I'm going into Actions. Note that the workflow header has passed successfully at this stage. But keep in mind that these headers are constantly different. Now, this was the commit title. The previous one was also a commit title. But when we created an issue, that was the header for the issue. When we made a pull request, it was something else. Right now, that was the commit title. The previous one was also a commit title. But when we created an issue, that was the header for the issue. When we made a pull request, it was something else. So GitHub is constantly using its own standard, but we can also keep track of that header. When we made the pull request, it was something different. So GitHub is constantly using its own standard, but we can also keep track of that header. I'm going to show you how to set it up. And let's verify the logs right now, immediately at this moment, to see if we're getting what we need. So the first object we get is the GitHub context object, which contains a lot of different information about our repository, like who the author is, the branch, and much more. We can use all this information when writing our workflow. The next object has a lot of data. The next object is the virtual machine, Linux, the path to various directories. We're getting information. Next, we have information regarding the job. I think, yes, so the job, what does it contain? It contains the status. This job has been completed successfully, so at this stage, it's just a success. And probably, because I don't have any previous steps, it seems. So in this step, it doesn't have any information regarding the current steps information at this point. But if I set it as the second step, let's try to implement that and observe. And let's also pass the header for Orflow and consider to set a custom header, which is a crucial step in ensuring that our data is properly labeled and easily identifiable. We need to use the run name parameter. This parameter allows us to specify a unique identifier for our run, making it easier to track and manage. And let's set our custom header, which in this case could be something like Project X Analysis 2023. Let's run it to see how it works in practice. Attention, I'm using updated as the header for the commit, but this time I'm going to use something other than the keyword updated. The reason for this change is to avoid any potential confusion or redundancy, as updated is a commonly used term that might not accurately reflect the specific changes or context of this particular commit. I'm going into the actions. Notice that my custom header, which I just passed, is now being displayed. And let's take a look at the logs one more time. This time we really are successful. The output of the object containing information about the steps, because if I try to output the object related to a step in one step, then it doesn't have any information yet, and I get an empty object. But if in the second step I refer to the context of the step, to get it, I get the content expression, which is nothing more than the ID of the previous step that we set, and we see that the conclusion is success, meaning it was completed successfully. So, as expressions, we have not only functions or context as we've been testing so far, but also operators, meaning logical operators. In one of the previous lessons, we already described such logical operators. Look, we used EF and made a comparison. And what were we doing? We looked at the context of GitHub, what our conclusion was for workflow.run, and if it was success, then we executed some step. So we've already worked with logical operators in this course. Let's take a look at what operators there are. I'll also include this link in the lesson description. And here are our operators, meaning equals, not equals, and or greater than, less than, and others. Besides the operators, pay attention to what types of data can be included in expressions. So, in expressions, we can have the type null, and we can have the Boolean type, which is either true or false, in our case, which we used in the previous lessons. A logical operator is used that ultimately returns a Boolean true or false. Next, there are integer numbers, meaning whole numbers. There are floating points. And note that there can even be negative ones. There are hex numbers. There are exponential numbers. There are simple strings. There are strings that contain, for example, some escaped characters, in this case, a quote. These formats can be used inside expressions without any problems. Next, regarding functions, we've only worked with one function so far, but in the next lesson, we'll work more with these functions. We'll use the contains function, which checks if a specific value, like another string, is present in an array of strings. Also, pay attention to join.toJSON that we used and the from_JSON function, which we'll probably use. So here in the hash files documentation, the functions that are available for writing instructions and creating workflows are listed. And there are also status functions that check for success, always, and cancel. We'll also work with them in the upcoming lessons. We've already talked about objects, and basically that's all there is to say about expressions. We'll get familiar with them. In the course, in the upcoming lessons, we'll work with them more and you'll solidify this knowledge. That's all for now. See you in the next lesson.